In the previous 9 episodes, I have presented a lot of information pertaining to human genetics with a particular emphasis on what distinguishes males and females. So what I would like to do now is to summarise the main points that I was trying to convey. So first of all, in episode 1, we learned that humans, along with other mammals, have a chromosomal XY sex-determining system. 99.75% of males have XY sex chromosomes and 99.85% of females possess XX sex chromosomes. Now, some people may be wondering where I got those figures from. Well, those have been specifically gleaned from the Britannica Online Encyclopedia under an entry titled Human Genetic Disease. And under this entry, we read this. About 1 in 400 male and 1 in 650 female live births demonstrate some form of sex chromosome abnormality. Okay, well, if 1 out of 400 males have a sex chromosome abnormality, that means 399 out of 400 males must have standard XY sex chromosomes without any obvious abnormality. And that's how I arrived at the figure of 99.75% for males. And alternatively, if 1 out of 650 females have a sex chromosome abnormality, that means that 649 out of 650 females must have standard XX sex chromosomes without any obvious abnormality. And that's how I arrived at the figure of 99.85% for females. However, this doesn't mean that that small percentage of males, 0.25%, and the 0.15% of females are completely mysterious and confusing to us. Because as we also learned in section 2, we learned about variations in sex chromosomes. For instance, we encountered males with Klinefelter syndrome, XXY. We encountered males with Jacob syndrome, XYY. And we also encountered males with XXYY sex chromosomes. Now, these individuals obviously do possess a sex chromosome abnormality, so they do belong to that small group of 1 out of 400, but they are obviously males, and we can know this by applying the simple principle, the possessor of the Y is male. They have Y chromosomes, so they have the genetic instructions that triggered male development in utero. Alternatively, in section 2, we also encountered females with Turner syndrome who have 1X chromosome and females with XXX syndrome who have a 3X chromosomes. Now, once again, they do possess a sex chromosome abnormality, so they do belong to that small group of 1 out of 650, but they are obviously female, and we know this by applying the simple principle, the possessor of the Y is male, they don't possess a Y chromosome, and therefore female development has proceeded instead of male development. Now, another important point that we learned in episode 2 was about a phenomenon known as X chromosome inactivation. Now, this is the process whereby extra X chromosomes get shut down. Now, this relates to females with standard XX sex chromosomes, but it also relates to individuals who have variations in sex chromosomes numbers, such as females with XXX syndrome and males with Klinefelter syndrome, XXY. And that's why I say that you don't need to get bamboozled when you encounter all these extra X chromosomes, and that's because the cells of these individuals are not getting bamboozled. They're keeping a track of the extra X chromosomes and they're shutting them down. In episode 3, we looked at the Y chromosome and how it is inherited from father to son like a surname, and we saw that Y chromosome tests reveal paternal ancestry, and in my case, my Y chromosome test revealed the deep ancestral group that I belong to. And we also saw that if you are female and you want to waste money, a good way to do this is to send in a DNA sample to a Y chromosome testing company and ask for a Y chromosome test. Alternatively, if you're female and you're interested in your paternal ancestry, ask your brother or your father to send in a DNA sample. In episode 4, we looked at how PCR can be utilised to determine biological sex in forensic science or archaeology. And in this case, we looked specifically at the amelogenin gene, which is found there's different versions of this gene on the X and Y chromosome, and so with a limited sample of cells, you could amplify the variants of this gene and determine the presence of sex chromosomes, and from there infer the biological sex of an individual. And this would even apply for an individual who has long passed away, as in the case of archaeology, you could still infer their biological sex. In episode 5, we first encountered the SRY gene, which is found on the short arm of the Y chromosome. And this triggers male development approximately 6 weeks post-conception. And the SRY gene is like a master switch that sets off male development. Now, the importance of the SRY gene cannot be overstated. It's really important to keep a track of this gene, see what it's doing and where it is. So, for instance, in the episode on genetic surprises, we saw that in some instances, the SRY gene can be translocated to an X chromosome, and this can result in an XX-SRY plus male. Alternatively, if the SRY gene is mutated and therefore rendered inoperative, or if it's deleted and therefore missing, this can actually result in an XY female. From there, in our section on hormones, we encountered 2 of the most important sex hormones, testosterone for males and estrogen for females. Now, we saw that if a female takes masculinizing hormone therapy in the form of testosterone, this can certainly masculinize some of their features, but we also saw that that can't transform their sex chromosomes. It doesn't erase one of the X chromosomes in each of their cells and replace it with a Y. Moreover, it doesn't erase the developmental pathway that they have already traveled down, and also it doesn't transform their gametes. Testosterone therapy won't convert one of it won't turn their eggs into sperm. Now, in the case of feminizing hormone therapy for males in the form of estrogen, we saw that it can certainly feminize some of their features, but it can't transform their sex chromosomes. It can't change one of their Y chromosomes into an X. It doesn't necessarily erase the developmental pathway that they've already traveled down, and it doesn't transform their gametes. It doesn't transform their sperm into eggs. In the section on genetic surprises, we saw that many disorders or differences of sexual development arise because of mutations or chromosomal aberrations of the XY system. But we also saw that research conducted in the past decade has shown that even though males and females possess roughly the same 20,000 genes, we're using approximately 6,500 genes very differently in one tissue or another. In the episode on epigenetics, we learnt that males and females are epigenetically different from each other. Males methylate the DNA in their sperm at imprinted genes in a male-specific way, and females methylate the DNA in their eggs at imprinted genes in a female-specific way. And we also saw that because males and females methylate their DNA in different but complementary ways, that's why for normal healthy development to proceed, you need a set of chromosomes from a female and a set from a male, because like I said, they're methylated in different but complementary ways. And then finally, in the section on defining biological sex, we saw that many biologists define biological sex according to the gamete type that's produced. Males produce sperm and females produce eggs. So we saw that males produce sperm and develop unique anatomy around the production of sperm, and females produce eggs and develop unique anatomy around the production of eggs. But we also saw that by keeping a fairly robust definition of biological sex in mind, you are less likely to be bamboozled when you encounter variations in sex-influenced traits or variation in secondary sexual characteristics, because males and females, populations of males and females vary significantly within those populations in regard to these features. So that is a basic overview of the main scientific points I was trying to convey in this presentation. But if you want to get all the details, you're going to have to go back and watch the previous 9 episodes. So what I thought I might do now to wrap things up is give a basic explanation about how this presentation came to be, along with a few other thoughts. Well, a couple of years ago, I gave a very brief presentation on genetics to a small group of teenagers at my church. I recognise that teenagers probably don't know much about genetics, and that makes it even harder for them to navigate this bewildering world we live in, where people often talk about human biology and human identity in such a confusing way. And so I reasoned if they knew more about genetics, that could clear away a lot of confusion. So what I started by doing was to look at some high school biology textbooks to see what teenagers learn about genetics in their final years of schooling. And I used that as a bit of a reference point to come up with a brief presentation. Now, the initial talk I gave to the teenagers at church, they seemed to be pretty interested. They asked some good questions. And I always think that's a good sign when you can keep the attention of teenagers. But after giving that initial talk, I thought to myself, I really should develop this presentation further, because by adding more detail, I can provide more clarity. And so that's what I did. I basically chipped away at this presentation over time, and it got longer and longer and longer. But it was actually a helpful exercise because it enabled me to clarify a number of things in my own mind that I was a little bit confused about beforehand. And so what I have presented here is a far more detailed version of that original talk I gave to those teenagers at church. That doesn't mean I'm claiming to have answered all the questions or anything like that, but I trust for most people who watch this presentation, I have been able to enhance their understanding of the topic significantly. However, by focusing on genetics, I don't want to give the mistaken impression that humans are just our DNA code and nothing more, because humans are far more than that. If we were just our DNA code and nothing more, our DNA, then my 2 aunties who were identical twins and therefore essentially had the same DNA sequence, then by that reasoning, my 2 aunties would just be 2 copies of the same person. But they obviously weren't. They were unique individuals in their own right. So there's obviously more to us than just our DNA, but at the same time, the DNA in our cells is a fundamental part of who we are. Moreover, as a Christian, I obviously believe that humans have a soul. And this is something that, one of the big differences that distinguishes humans from any form of artificial intelligence. But don't ask me to tell you which human chromosomes contain the genetic information for the human soul, because I actually think that's the wrong question. As far as I'm concerned, the soul is immaterial. Also, as a Christian, I believe that the ultimate answers to human identity are not found by looking inside ourselves, but by seeking God for the answers instead. One of the things that has struck me as I've put this presentation together is the extent that some people are going to change themselves. People are obviously taking hormones, they're having surgery and making other changes. I suspect for some people, part of the reason this appeals to them is it provides them with an opportunity to start a new life with a new identity. It's almost like you hit the restart button on your life and get a fresh start. And who wouldn't want that at times? Somewhat surprisingly, restarting your life with a new identity actually has some striking parallels to the Christian faith. Now, what do I mean by that? Well, one of the central claims of Christianity is that about 2,000 years ago, God took on human form and came to this earth in the person of Jesus. Jesus' death and resurrection paid the penalty for human sin and provided a means by which people can be reconciled to God, provided they respond to that offer of reconciliation in repentance and faith. For people that do respond in that way, they do actually start a new life with a new identity. Jesus said, "You need to be born again." That certainly sounds like starting over. Jesus also said that those who believe his message pass from death to life. That sounds like a really, really significant change. The New Testament also says that those that put their faith in Jesus actually become a new creation. That sounds like getting a new identity. Now, I know I'm admitting my own Christian bias here, but as far as I'm concerned, when someone responds to that message of reconciliation to God in repentance and faith, the change that occurs is far more significant than any change, physical change that we can make to our physical bodies. Now, some of you might be thinking, okay, what happened to this guy? He was talking about genes and chromosomes for a few hours, then all of a sudden, he's gone a little bit weird and religious on me. Well, what's going on here? Well, maybe I'm a little guilty of that, of doing that right at the end. But one thing I will say in my defense is this talk actually started in church. Remember how I said it started with a brief talk to the church youth group. So if it started in church, I think it's okay if it finishes sounding like something you might hear in church. In fact, I think that's the best way for it to finish. So on that point, I really am going to wrap things up and finish now. I hope that you've learnt a lot in this presentation, and I trust that I've also given you some other things to ponder at the end as well. And I want to thank you for listening to me all this time, particularly those that have listened to me for the entirety of this presentation, because if you have, you've been listening to me for over 3 hours. Yes, that's right, 3 hours. Thanks for listening.